Hello and welcome to this special lesson on converting rectangular equations to polar equations. So as we know, a rectangular equation is something written in the term like 3x in terms of x and y. And a polar equation is something written in terms of r and theta. So, those are the polar coordinates. Polar equations are written in terms of x and y still, and polar equations are written in terms of r and theta. So our goal today is to take a rectangular equation and convert it to a polar one. So we're going to change all of the x's and y's into r's and thetas in some way, shape, or form. So our goal ultimately is to isolate r if we can, and if we cannot, or if r cancels out, then we isolate theta. Okay, so we do need to recall a couple things. For instance, our equations for converting. In this particular case, we have x and y. X is equal to r times cosine theta, and y is equal to r times sine theta. And anytime you have a rectangular equation, anytime you have an x or a y, you could substitute those x and y's into r cosine theta and r sine theta. So in this particular equation, I'm going to take this, I'm going to put the x's and y's in parentheses, and whenever you see that parentheses, you're going to plug in r, for x anyway, r cosine theta. We have a minus sign between them, and there's nothing in front of the y, so this is going to turn into r sine theta. And set this equal to 1, bringing it down. And now, we want to isolate r. And the way we would do that is we would definitely look at how many terms we have. Here we have 2. And if you notice, we have r in both terms, which means we could factor it out. Our GCF here is going to be r. So if we have r as a factor GCF, we divide r from both terms, and we end up with 3 cosine theta in the first term. These cancel out, and you get minus sine theta is equal to 1. Okay? And here, we would get r by itself by dividing out the 3 cosine theta minus sine theta. Anything you do to one side, you do to the other. Divide by 3 cosine theta minus sine theta. And those cancel out. R is then equal to 1 over 3 cosine theta minus sine theta. And this is our polar equation. Okay, and we are done. Now, remember what I said about having a graph and something written in polars. If I had 3 comma 4 as a coordinate, we've got 3 to the right, 4 up, and then we would graph it, and then this is our x, this is our y, but then we would solve for r and theta. The same idea actually kind of happens, except these 2 equations are going to be the exact same if we threw them in Desmos. So if, for instance, I pull up Desmos, and I have this here, 3x minus y, that is our, let me change this back to rectangular, that is what our graph will look like. So it's just a straight line, it's a slope form. Y is equal to mx plus b would be y is equal to 3x minus 1. Okay? And if we convert it to the polar like we have in the second line, it overlaps it. It's the exact same equation, and it's just the exact same thing overlaid into a polar graph. Okay? So, we do the same thing for this equation. So if you're feeling brave, you could try this out. Anywhere you see an x, you substitute r cosine theta. Anytime you see a y, you substitute r sine theta. So if you want to pause this and give this a shot, go for it. If not, just keep following along. Y is r sine theta minus 8 times r cosine theta. And this is all equal to 16. We have r in both terms. So I'm going to divide out an r, because that's our GCF. You end up with sine theta on the inside minus 8 cosine theta is equal to 16. You divide both sides by it. And I'm just gonna do one long division symbol here because I don't wanna have to write this twice. Divide by sine minus 8 cosine theta on both sides. And you get r is then equal to 16 divided by sine theta minus 8 cosine theta. Okay? All right. Now, we could always graph this as well if we doubt what it looks like. I'll let you try that and you can do that on your own. But we're going to move on to the next one. This equation, we should know what this looks like just by thinking about it. X is equal to 4. This is a vertical line where the x value will always be 4. Okay? If we graph this, we should see that line. But all we have to do in this particular equation is substitute out the x with cosine theta, r cosine theta. And in this particular equation, you don't have to factor anything because there's only one term. But we do need to get r by itself. So that means we need to divide out this cosine theta. Cosine thetas on the left cancel out. You get r is equal to 4 over cosine theta. Okay? And we could always check that as well. In fact, let's do it. Here's x is equal to 4. As we mentioned, I'm going to keep this in polar. It's no different. And then if I show the r is equal to 4 over cosine theta, we get the exact same graph. Okay? So, back to notability. We are done once we have it in the polar form. R is by itself. Now, this one in particular is a little bit interesting. Y is equal to x. We know what this should look like, hopefully. It should be a very straightforward. Slope is 1, goes through the origin. This is what the graph should look like. There are two ways to do this problem. I'm going to show both of them, and I'm actually going to move this over to the far right, just because I'm going to need to divide this. Okay, let's put a dividing line here so it separate the first version versus the second. If I did this, r times sine theta is equal to r times cosine theta, then I could bring this to the left side. So all the r's are on the same side. R sine theta minus r cosine theta is equal to 0. Now we could GCF this. We had r is equal to, r times, I should say, sine theta minus cosine theta after you divide out the r's. Then we set it, this is your factoring, so you can say r is equal to 0, which doesn't really exist on our polar, it's a polar equation. It's just the origin, which has no actual radius. And then we end up getting sine theta minus cosine theta is equal to 0. Well, how do you solve this? Well, this one washes away. We don't have an r in this equation, so in this particular case, we would solve for theta. If r's cancel out, or if we don't have an r, we solve for theta. So the way we would do this is we would add cosine back. We end up with sine theta is equal to cosine theta. And then this is kind of the weird part, we would divide by cosine theta on both sides. Cosines on the right will cancel out and you get 1. And you end up with sine theta over cosine theta, which hopefully is familiar because sine over cosine is tangent theta is equal to 1. This occurs, there are two solutions to this, hopefully you know. When tangent theta is equal to a positive 1, it occurs at pi over 4 and 5 pi over 4. And if you really, really think about it, it is at these particular points. Pi over 4, 5 pi over 4. When this happens, you kind of just connect the dots and you make the line. And you're done. Now the second way to do this is actually a lot easier. Okay, I'm going to take this version of it. R sine theta is equal to r cosine theta. And then divide out the r's. R's cancel out, and you end up with sine theta is equal to cosine theta, which is the exact same thing we had right here. You divide cosine theta, you get 1 on the far right, because they cancel each other out. You get tangent theta is equal to 1, which is the same answers. Pi over 4 and 5 pi over 4. Okay? All right. Not the second to last problem. Here we have x squared plus y squared is equal to 3, and we need to do a recall. So one of our equations that we worked with converting is x squared plus y squared is equal to r squared. And notice our equation has x squared and y squared in it. So if we have this, it would actually be a lot easier than doing this. R cosine theta squared plus r sine theta squared. I would not want to do this. Hopefully I should have done this in pink. Sorry if you did it. I would not want to do this. This would be quite frustrating to do. Okay? So, because what would happen is this becomes r squared cosine squared, and then r squared sine squared, and we know cosine squared plus sine squared ends up equaling 1 when we factor out the r, and then it'll all kind of wash away anyway. So, if you recognize this, and if you see the x squared plus y squared in any way, shape, or form, you could replace this with r squared. R squared is equal to 3, and if we wanted r by itself, we could just divide by square root, and we get r is equal to plus or minus root 3. Okay? And then last but not least, this one is the tricky one, the tough one, and we are gonna use this trick in this particular problem, the recall, what we just did. Now, when you square something, this is personally what I would do to start off this problem. I would not substitute cosine, r cosine, or r sine in right away. I would wait, okay? Because foiling this out with r sine theta and r cosine theta is a pain. I would FOIL this out first properly, or distribute. X plus 3 times x plus 3 should end up being x squared plus 6x plus 9. And then the y's would be y plus 3 times y plus 3, which gets you y squared plus 6y. Yeah, sorry, I'm just making sure I copied the problem down correctly. Plus 9. And then there's a plus between these, and then there's a minus 18 on the tail end, is equal to 0. Now, combining like terms is going to be helpful because we have a plus 9, and a minus 18, which all kind of wash away, which is really, really nice. We also end up with, well, this is what we'll end up with, x squared. And for the sake of it, let me do this. I'm going to box this and the y squared. X squared and y squared, I'm going to keep next to each other. I'm going to put the plus 6x plus 6y is equal to 0. And then we know that this x squared plus y squared could turn into r squared. So r squared plus 6, and then now this is when I would substitute. Okay? So we end up with r squared plus 6 times r cosine theta plus 6 times r sine theta is equal to 0. Now we could GCF this. There are 3 terms, all of which have at least one r, so we could factor out one r. So we get r is equal to, r times r plus 6 cosine theta plus 6 sine theta is equal to 0. Once again, you break this up into 2 different equations. R is equal to 0. Doesn't really exist. That washes away. And then we end up with r plus r, 6 cosine theta plus 6 sine theta is equal to 0. We need to get r by itself. So I'm going to subtract 6 cosine theta and subtract this 6 sine theta at the same time. To the other side, we'll end up with r, oopsies, let me just show the work for it, minus 6 cosine theta on the right side as well, minus 6 sine theta, and we'll end up with these canceling out. R is then equal to negative 6 cosine theta minus 6 sine theta. And we are done. Okay? So this is your polar equation. We ignore the r is equal to 0. That doesn't really do anything for us. Okay? All right, so those are your converting rectangular equations to polar equations. If you do have any questions, please ask when we get to class, and I will happily answer them. All right, have a good one. Bye.